Hello everyone, today's YouTube video tutorial is going to be on specific heat calculations. And so we deal with this formula that has four little variables that we're going to cover how we can find or solve for each of those variables. But it starts with Q equals M times Cp times delta T. Okay, so we're going to go over each variable and what they mean. Okay, for the first one, Q, that stands for heat energy. So this is either the heat that is absorbed or given off. And we usually see it in units of joules. For M, it's going to stand for mass. And mass is going to be expressed in units of grams. This capital C with the P is going to stand for specific heat. And that one, we see a little bit more of a complicated unit, and that's joules over grams times degrees Celsius. And then last but not least, we have delta, which is stands for change in temperature. And we usually see that expressed in Celsius. And for the delta T, the change in temperature, it usually requires you to subtract the final temperature by the initial temperature to get that change. Okay, so there are several variations of this one formula. In other words, we can manipulate the formula mathematically to solve for M, to solve for specific heat, and to solve for change in temperature. If we're trying to find mass, then it's going to be Q divided by specific heat times the change in temperature. If we're trying to find specific heat, we're going to do Q over mass times change in temperature. And if we're looking for delta T or change in temperature, it's going to be Q over mass times specific heat. And so this is what we're going to deal with in the following examples. Okay, our first example is asking the following. It says a 45-gram sample of iron is heated from 25 degrees Celsius to 50 degrees Celsius. How much energy is required? It also tells us that the specific heat of iron is 0.449 joules over grams times degrees Celsius. So the main question here, which I went ahead and underlined in red, is it's asking how much energy. So let's go back and look at the formula manipulations. So since this particular problem is asking for how much energy, we can readily say that what we're going to be searching for is Q. And this is a formula that we're going to use. So let's go ahead and set it up. Okay, just a quick piece of advice for these problems as we go through them in this lesson is for you to go ahead and write down all the variables that are involved. So your Q, your M, your Cp, your delta T. The other thing that I could suggest you do is write the unit that goes with that variable. So we know, as we said before, for example, if we're looking for Q, it's going to be a number that has joules. So as you go through the question, if you find a number, for example, this one, it says 45 grams, then you know that since it's grams, that will be mass. Okay, so then we go ahead and write down that mass is 45 grams. All right, the next thing we see is that it says that it's heated from 25 degrees Celsius to 50 degrees Celsius. And if we look at our little chart, we know that if something is in degrees Celsius, that would be the change in temperature. So therefore, we know that that's where this goes right here. And don't forget that change in temperature is going to be the final temperature minus the initial or starting temperature. As we continue reading, it says how much energy is required. So that means that Q is our unknown. The specific heat of iron is 0.449 joules over grams times degrees Celsius. Okay, so now we can go ahead and fill that out because we know that specific heat is given to us. Okay, so recall that we're using the Q equals M Cp delta T formula. So we're going to go ahead and substitute everything. And here you're going to see that I've already subtracted the 50 degrees Celsius minus the 25 to give us a change in temperature of 25 degrees Celsius. So as we look at how we place it into the formula, we substitute all the numbers in. substitute those variables. And now what we're going to do is multiply them all across. So 45 times 0.449 times 25. Okay, once we do that, we find out that Q is equal to 505.13. And I went ahead and rounded to the nearest hundredth. And then the unit that I'm using for Q is joules. Not only do I know that it's joules because that's part of my notes, and that's something that we just discussed, that if it's heat energy, it's going to be expressed in joules. But if we also cancel the like units, we'll find out that our remaining unit is joules. So grams cancels with grams, Celsius with Celsius, and we're left with joules. And that is the answer for our first example. Let's go ahead and go to the next. Okay, for our next example, it reads as follows. It says, what is the specific heat capacity of an object if a 12.5 gram sample is heated from 12 degrees Celsius to 28 degrees Celsius using 100 joules? Okay, so if you notice, I also went ahead and underlined what they're asking us to find. So in this case, they're asking for specific heat. So I can either go up and go look and find the specific heat formula, which was given to you with all the formulas. So now I know that I will be using this particular formula, but I can also go ahead and just see what the variables are given to me, what they are and what I'm missing. And like I said before, you can go ahead and write them all out and just go ahead and fill in them as you read through the question. Okay, so we know that Q is given to us because we have a number that is stated there and it says 100 joules. For mass, we also know that that's given to us because we have a number with grams and it reads as 12.5 grams. For specific heat, I notice that there's not a number that has joules over grams times degrees Celsius. So that's going to be our unknown. And that's the formula that we'll be using to find the specific heat. And for change in temperature, you're going to notice that they do give us numbers that are in degrees Celsius and they do give us the final and the initial. So we're going to go ahead and do that simple math of subtracting 28 degrees Celsius, which is our final temperature, minus our initial, which is 12 degrees Celsius. And then we end up with 16 degrees Celsius. All right, so we're going to put it all together in this one formula. Okay, as we substitute the numbers, you'll find out that we have 100 joules divided by 12.5 grams times 16 degrees Celsius. So you go ahead and multiply these two. Whatever your answer is, you're going to take your top number and divide it by the bottom number or the bottom answer. And once you do that, we find out that our answer is 0.5 joules over grams times degrees Celsius. Notice that we did not cancel any units. Not only can we tell from the notes that that's going to be our unit for specific heat, but we also can tell from how we set it up. And because there are no like units, none of them canceled. And then we're left with the same units from the setup. So this is the answer to example 2. Okay, so now looking at example 3, it's asking what is the mass of a piece of iron if it has a specific heat of 0.449 joules over grams times degrees Celsius and the temperature changes from initially being 70 degrees Celsius to 93 degrees Celsius. The energy required for this change is 800 joules. And like I said before, you can have this little setup done for yourself already, and all you have to do is place the numbers that are given to you in the question here so you can find what your unknown is. Other than that, guys, if you read it, it is asking you what the mass or what is the mass, so we know that our unknown is going to be M. All right, so now substituting those numbers to those variables, we're going to find out that if we look at this side by side, so remember for Q, we're looking for a number in the question that has J for joules, and there it is, it's at 800, so Q is 800 joules, that's how I knew that. Okay, for mass, we didn't see a number that had grams, so that's going to be our unknown. Therefore, this is a formula that we will be using. For specific heat, we're looking for a number that has joules over grams times degrees Celsius, which in fact we did have, and that's the one I went ahead and put down for specific heat. And then last but not least, For delta T, or change in temperature, we're looking for numbers that have degrees Celsius. In this case, we had our final temperature and our initial temperature, which we did subtract to get a 23 degrees Celsius as our change in temperature. So now all we have to do is go ahead and plug it into the formula and put it into the calculator. Okay, so as we plug in the numbers, we're going to have 800 divided by, and then we have to multiply these two first, which is 0.449 times 23. So once we multiply the two bottom numbers, we're going to divide the top number by the bottom, and we end up with 77.47 grams. And again, this is rounded to the nearest hundredth, and that is our answer for what is the mass, or what was the mass, with the rest of the information provided. All right, so we're down to our last example, and we've gone over all the variables, almost all the variables in that formula. So we're down to the last one, and if we go through the question, you're going to find out that it's asking you for change in temperature this time. So it reads, a 20-gram gold sample absorbs 275 joules of heat. What is the change in temperature of the gold if it has a specific heat of 0.129 joules over grams times degrees Celsius? So again, we're going to go ahead and set it up based on this information. Okay, so here we have our side-by-side view. So we know that Q is going to be a number that has joules, and if we go through our question, there it is. So 275 joules go here. For mass, we're going to have a number that has grams, and sure enough, there it is. So 20 grams goes here. Specific heat, here are the units, joules over grams times degrees Celsius, which again, it's given to us, so it's 0.129 joules over grams times degrees Celsius. And then last but not least, delta T. And if you notice, there's nothing here with just Celsius. I mean, granted, yes, we're looking at this one, but all these three units together, that's for specific heat. So when you're looking for delta T, it should just be Celsius. Okay, so since we know that delta T is our unknown, this is a formula that we're going to go ahead and focus on. All right, so we're kind of looking at the same scenario as the rest. So we have 275 joules, and that's going to be divided by what you get when you multiply 20 and 0.129. Okay, so multiply the two bottom numbers, and then you're going to divide the top number by the bottom answer. Okay, so let's go ahead and do that. Once we plug it into our calculator, we are going to find out that delta T is equal to 106.59 degrees Celsius. And that's all you have to do for the delta T, because that already gives you the change in temperature. You don't have to subtract like you did before. That's only if you're giving two temperatures, your final and your initial. But in this situation, since we're going to have to, or we had to calculate delta T, it's already done for us, and we're done with this problem. It was 106.59 degrees Celsius. And in fact, we're pretty much done with specific heat examples. So this is what you're going to use as your basis to answer the questions that follow. And you will also see the solutions on the slides that are provided for you in the Nearpod lesson. But don't forget, and just a quick reminder, if you need any help, we are there to help you guys out. Don't forget that we also have our virtual meetings for every class once a week. So just let us know if you need anything. Thanks again.